How does a solar panel work? Solar energy is a renewable and abundant source of energy that has the potential to meet the world's demand for energy. However, there are some challenges that need to be addressed before solar energy can become the dominant energy source in the world. The Earth, that immense blue dot in the vast cosmos, is constantly bathed in an astonishing amount of solar energy, approximately 173,000 terawatts, a power that exceeds the energy consumption of the entire world population by 10,000 times. So, could the day come when the entire world is completely dependent on solar energy? To answer this question, it is essential to unravel the intriguing process by which solar panels transform sunlight into usable electrical energy. Solar panels, made up of tiny units known as solar cells, play a central role in this feat of engineering and science. At their heart, these solar cells, which are the fundamental units of power generation, are made mostly of silicon, the second most abundant element in the Earth's crust. Crystalline silicon forms a network of connections between its atoms, which normally prevents the flow of electrical current. However, the wonder of the technology lies in the use of different layers of silicon in a solar cell. An N-type silicon shell holds extra electrons, while the P-type shell offers spaces, known as holes, that can hold electrons. When these two layers merge, an electrical potential difference is created at the P-N junction, generating a positive charge on one side and a negative charge on the other. Herein lies the secret. When photons of sunlight, those energy-carrying elementary particles, hit a silicon cell with the necessary force, they can release an electron, leaving behind a hole. This charged duo, the electron and the hole, move in opposite directions due to the electric field at the P-N junction, thus establishing an electric current. Through clever designs, electrons flow into metal fingers at the top of the cell, then travel through an external circuit, doing electrical work on their way, before returning through a conductive layer of aluminum at the rear. Uniquely, each solar cell generates as little as half a volt, but combining multiple cells into modules unleashes a more powerful electrical symphony. Astonishingly, in just 12 photovoltaic cells, a mobile phone can be charged, while an entire house requires multiple modules to meet its energy needs. And the most impressive thing is that, in this energetic dance, the electrons are the mobile protagonists, and they always return to their starting point. This means that solar cells can last decades without any wear. However, before we plunge into an all-solar future, we face physical and logistical challenges. The irregular distribution of solar energy on Earth, its variations according to the climate and the need for effective storage represent essential obstacles. The sunny areas must share their solar wealth with the cloudier ones, and the energy must be able to be stored for continuous use. The efficiency of solar cells also raises questions. If sunlight is reflected rather than absorbed, or if electrons stray before going through the circuit, the photon's energy is dissipated. Even the most efficient solar cell converts only 46% of available sunlight into electricity, and most commercial systems achieve efficiencies between 15% and 20%. However, despite these challenges, the possibility of powering the entire planet with solar technology is not an unattainable dream. Financing is required for the necessary infrastructure and a considerable extension of land. As imposing as these demands may seem, the Sahara Desert, with its 8 million square kilometers, could hold a solution. And while the sun is shining brightly, solar cells are constantly improving, falling in cost and competing with conventional electricity. Innovations like floating solar parks can revolutionize the industry. Ultimately, solar power can bring hope to more than 1 billion people who lack reliable access to the power grid, especially in sunny regions of developing countries. Another challenge is the cost of solar energy. Solar panels are still relatively expensive, although their cost has been declining in recent years. The cost of solar energy is expected to continue to decline as the technology develops and the scale of production increases. Despite these challenges, solar power has the potential to be a clean, reliable, and affordable source of energy. As technology continues to develop and costs decline, solar power is likely to play an increasingly important role in the global energy mix. Here are some of the benefits of solar energy. It is a renewable energy source, which means it does not emit greenhouse gases that contribute to climate change. It is a clean energy source, which means it does not pollute the air or water. It is a reliable source of energy, since the sun is available every day. It is an affordable source of energy, since the cost of solar panels has been decreasing in recent years. Solar energy has the potential to provide a clean, reliable and affordable source of energy for the world. As technology continues to develop and costs decline, solar power is likely to play an increasingly important role in the global energy mix. As we explore the wonders of solar energy conversion, it becomes clear that we are witnessing a momentous change in the way we get and use energy. Solar panels, with their choreography of electrons and holes, remind us of the vastness of the energy source that unfolds above us day after day. Although challenges and questions remain, the path to a brighter solar future is lit by the promise of clean, abundant and sustainable energy for generations to come. And you, what do you think about it? Do you think solar energy is the future? Or it's just going to be a complement to fossil fuel energy? Let me know in the comments, and if you liked the video, I ask you to give it a like, to subscribe to the channel so that YouTube notifies you when we upload a new video. Until next time.